Students, in this lecture we are going to discuss about the two-dimensional elements. So before going to discuss about the two-dimensional elements, let us go through the coordinate system, where coordinate system plays an important role in the entire FEM. So in this coordinate system, it is divided into three types. One is the local coordinates, another is global coordinates, another one is natural coordinate system. Earlier you know about this Cartesian coordinate system and radial coordinate system. So Cartesian coordinate system will be represented as x, y, z in the space. So those Cartesian coordinates are furtherly classified into these three types. So in this first of all, let us go discuss about the global coordinate system. So global coordinate system is referred as the space coordinate system also. So where it refers as the points in the entire structure are defined using this coordinate system is known as global coordinate system. So entire structure will be represented with a reference point. Those are termed as global coordinate system. Let us see here. It is given an example of a triangle. So in this there are four nodal elements. Each node will be represented with respect to a reference point. Those are termed as global coordinate system. Or let us see here an example. If it is a space coordinate system, so x, y and z. In this, if we place an element or a brick is placed on the earth surface, so this brick has how many nodal points? 1, 2, 3, 4, 5, 6, 7, 8. 8 nodal points are there for this brick. So in order to identify this brick, or in order to find the deflections or displacements in this brick when a force is applied, we need a coordinate reference point. So for this brick, the coordinate system will be coordinate system referral point will be 0, 0, 0. So this origin point will be a reference point with respect to a reference point. We are placing the coordinates for this brick or for a structure. Those are termed as global coordinate system. We're coming into the local coordinate system. In FEM, separate coordinates is used for each element as local coordinates. Each element properties can be defined in this, but the final equations are to be formed only by global coordinate system. Here a link is established between the local and global coordinate system. Let us know about this. Here the global coordinate system here I have given one example of a brick. So for this particular brick, it is in a three-dimensional form where it has x, y, z. So using those coordinate system, framing a stiffness matrix is very difficult. So directly solving the three-dimensional element will be difficult. So we will discretize those particular element into a two-dimensional body. So two-dimensional means two-dimensional planes means all the faces will be divided. So cube has how many faces? Or brick 1, 2, 3, 4, 5, 6. 6 faces will be there for a brick. So the faces means the plane surface. It has rectangular plane surface and square plane surface. So we will discretize that 3D element into a 2D element. So in this 2D element, earlier the three-dimensional element has how many nodes? 8 nodal elements. So framing a stiffness matrix for this 8 nodal element will be 8 into 3, 24. 24 by 24 matrix will be a difficult task to be performed. So in order to that particular element is discretized into 6 faces or 6 plane elements. In these plane elements, each element has 4 coordinates, 4 nodal points. So each node has 2 degree of freedom. 4 2s are 8. 8 by 8 matrix can be framed. So after discretizing the parent element into a number of sub elements, those sub-elements need to be referred with a coordinate system. Those coordinates are termed as local coordinates, which means whatever the coordinates we are giving for the parent element, those are termed as a global coordinate system, whereas after discretizing the parent element into a number of elements, for that we are giving some coordinate reference points. Those are termed as local coordinate points. After finding the stiffness matrix for this using this local coordinate system, again we will assemble those 6 elements into a parent element. That will be done by assemblage of matrices. Then those stiffness matrix will be referred to the global coordinate system. Okay. Another one is natural coordinate system. So in this natural coordinate system, whatever we discretized, earlierly we discretized those elements into a rectangular or square elements. Again here also what I said, each node has 2 degrees of freedom. So the matrix will be 4 by 2 matrix. So 4 to the 8, 8 by 8 matrix. 8 by 8 matrix also sometimes it will be difficult. In order to discretize that, this rectangular element again is divided into a 4 elements, 4 sub elements or 4 line elements. If we divided that rectangle into a 4 line elements, means where it has 2 nodal points. So 2 nodal points means 2 by 2 matrix, where each node has 1 degree of freedom only. Line element has 1 degree of freedom because it will be represented in the x direction only. So we can easily frame the 2 by 2 matrix. Again the 2 by 2 here how many 2 by 2 matrices will be required? Here we are having 4 elements. So 4 2 by 2 matrix we will assemblage in as a single 8 by 8 matrix. After that 8 by 8 matrix again we will assemblage as a 24 by 24 matrices, where it will get the stiffness matrix for a stiffness matrix of a cuboid element or a brick element. Okay. Now coming into the natural coordinate system, a natural coordinate system is used to define any point inside the element by set of dimensionless numbers whose magnitude never exceeds unity. This system is used for in assemblage of matrices. After dividing this parent sub element into another sub elements, so here we are represented as a line element. In this line element we need to, this is first node, this is second node, we need to identify an inside element. Let us take it as a P. This point will be a P. These coordinates will be zeta comma neta. Wherever we are finding an unknown point inside the sub element, those are termed as natural coordinates, which will be represented as zeta comma neta, where earlier in the local and global coordinate system we referred as x comma y and x comma y comma z. In the natural coordinate system, in order to find the coordinates inside the element, we will use this natural coordinate system. Those coordinates are termed as zeta comma neta. These values lies between 0 to 1 only. It will never exceeds the 1 value. Okay. This is regarding the coordinate system.